Okay, good morning everyone. Hi. Oh, that's very nice. Hi, my name is Felix. I'm a staff engineer at Slack, which is a little chat app. It's not super widely known. We're now 3 years old. Could I get a quick show of hands? How many people here know about Slack? Okay, that's a few. Oh, good. Nice. Great. As a company, we're still just 3 years old, so it's always nice when I go to conferences and I see that people actually know the company and have heard about it, which is helpful. I built the desktop application at Slack. That is what I do. Yes, thank you. Gentleman in the front is running it right now. So if any of you have the Slack desktop app or use the Slack desktop app, it is written in JavaScript, and it is written in the technology that I'm going to be discussing today and explaining in a little bit of detail, to just explain how you can build a cross-platform application with a very small team. Slack's mission is to make people's working life a little bit more simple, more pleasant, and more productive. That is what we do. We currently think that building a chat app is the best thing that we can do. We currently think that Slack in its current form is our best attempt in making people's lives better. But this obviously also includes the people who work at Slack, the people who have to build Slack day in and day out, the people who make Slack possible. So what I always like to point out when it comes to building desktop apps in JavaScript and building desktop apps with the software that we'll be discussing today is that Slack, the thing that you're seeing right now up on screen, is being built by a team of 4 people. Just 4 people. And that often surprises people because we're a very small team, but it's not unique for desktop apps built with JavaScript. It is more common that teams are very small. Visual Studio Code had, in the beginning, it's slightly bigger now, but in the beginning it had only about 5 engineers working on Visual Studio Code as meant by Microsoft. So what we will really be discussing is how to be extremely effective when building a cross-platform app, how to reach as many people and as many customers as possible with one little application. Okay, so let's briefly talk about platforms. Let's talk about operating systems that you want to target when you build an application. The first one is obviously Windows. That's the biggest one. That is where most of your customers will be. That is where most of Slack customers are. Obviously, there's Windows 10, which is a platform that maybe some of you are familiar with. Microsoft released a new way of building applications around Windows 8 called UWP. Back then it was called something else, but that's essentially how we build applications for Windows 10. Then there's the Windows Store, which some of you might know, which is not exactly the same as UWP. It's a slight alternation on it. So that's yet another platform you want to target for. And then, of course, Windows 7 is still pretty strong. Is anybody here still running Windows 7? Yes, a few hands. Did you know that Windows 7 is older than the iPhone? As the person who has to build apps for Windows 7, please upgrade. It is doing basic things like adding emoji support is extremely difficult. But yeah, if you build an application for Windows, those are the 3 platforms you need to target. So right there, you basically have 3 teams. And then for Apple, we have Mac OS, which is the operating system many of us know. But then we also have the Mac App Store, which is a different environment. If you want to build an application for the Mac App Store, you can't just take a Mac application. There are different things you need to consider. And then at the very end, we have Linux. Linux is, of course, insane, by which I mean that there is about 1,000 different binaries. You can't build one Linux app. That doesn't exist. There's obviously Ubuntu, which is the biggest one. But then there's also Red Hat, Fedora, which is the RPM package, which is what we also build. So in my world, I'm thinking about Linux as those 2 things, But there's more, right? There's the Ubuntu App Store. Those are just the two that I think about. So the point of this slide is really to show that if you build a desktop application that is not cross-platform, you need to hire at the very least. If you're not crazy, you need to hire at least just 6 people for Windows, another 4 for macOS, and then maybe you don't have that many Linux customers, so you only hire 2, right? But that already there is a team that is about 4 times the size of what Slack's team is today. So the solution is obvious. The solution is that you build one application that shares as much code as possible between the platforms. Right? You try to minimize the amount of code you have to write again over and over and over again, because quite frankly, if you look at Slack today, the chat window, right, the core thing that you see, looks the same on an Apple and on a Windows machine. It looks the same. There are differences in how the notifications look. The input is slightly different, right? IME input, for instance, works slightly different on Apple than it does on Windows, but the core application is the same. So let's talk about why you would build desktop apps in JavaScript. Usually when I go to conferences and I give a talk like this, where I talk about how Slack thinks about desktop applications and how I think about desktop applications, I usually get somewhat weird reactions. The first one is from the group of JavaScript developers, JavaScript engineers, who think that JavaScript is limited to the browser on Node.js. They usually are a little bit, they don't feel great about the idea of building desktop apps with JavaScript. And then there's the other side, which is native engineers, where I'm coming from. I'm an old Windows engineer, that also think that building desktop apps in JavaScript is a crazy idea, because obviously you should build fully native apps, right? If you're on a Mac, build them in Objective-C. If you're on Windows, build them in C# or C++. And if you're on Linux, build them in whatever you feel like is necessary. Maybe just build a command line client, right? And then you're done. The truth is that you're likely already running a desktop app written in JavaScript. If you're running Spotify, Atom, Visual Studio Code, Zeit, the new Visual Studio installer. The Visual Studio installer is written in JavaScript, which I think might be my favorite example. There's tons of applications written in JavaScript, and there's even more applications that come with JavaScript. If you have ever used any Adobe product, like Photoshop, anything in the Creative Suite, you have ran Node.js. As soon as you start Photoshop, you start Node.js. If any of you have a Windows computer with NVIDIA graphics drivers, you're also running Node.js. That's how NVIDIA does web things. It has a Node.js runtime included in every single driver. So Node.js and JavaScript is already likely on your machine. So if you think about desktop application development in JavaScript, it's not really adding anything new to your environment. It's already happening, right? Whether or not you like it. Okay, so I will be talking about Electron, which is a framework that we use at Slack. It's a framework that I'm a big fan of, and it's a framework that makes building desktop apps with JavaScript extremely easy. And it consists of 3 main parts. The first one is Node.js. Node.js is popular. It's the most popular developer environment out there, just in sheer numbers, but also in what people usually say, how they feel about it. There's been a big international Stack Overflow survey where people have pretty unanimously said, yeah, Node.js is pretty good. And that's how we feel about it. Building a Node.js is already cross-platform. You already write code. Node.js is very good at taking JavaScript and turning it into something that is extremely fast. If you write simple operations and simple instructions, sort of like you would write in C or C++, if you know how the machine operates, it's extremely easy to write code in Node.js that is very fast. The second part is Google Chrome, specifically Google Chromium, or a thing called the libchromium content. It is not all of Chrome. This is a common misconception when people think about Electron or Electron apps. Thank you. Yeah, it's a common misconception that Electron contains all of Chrome. That is not true. It just contains the little thing that makes pixels appear. It's just the rendering engine. So that is obviously also amazing. If any of you ever did any web development, it is obviously extremely nice to build for a modern platform, right? The thing that holds web development back is really that you can't build for Chrome 60, which is where we are right now. You need to build for Internet Explorer 9, or whatever the lowest common denominator in your environment is. In Electron development, you know what your lowest common denominator is. It's Chromium, this specific version, the version that you're shipping. So when I use Babel, or any transpiler, any JavaScript transpiler, if any of you are using any of them, like Babel or TypeScript, we just turn it off. We don't need it because we're just targeting Chromium, nothing else. And then the last part is C++. And that's usually where I lose people. Again, I'm going to be asking many questions here, but how many people are still writing C++? Okay, yeah. That's an accurate representation because, of course, C++ is terrible, right? Nobody enjoys writing in C++. But here's the cool part about C++. It is extremely performant. It is the fastest thing you can use today. It is cross-platform by nature. You can run C++ likely on your toaster. It's going to run everywhere. And lastly, it is extremely common. Right? It's easy to find documentation. It has been around forever. It is not this new cool hip thing. It's very easy for you to find solutions if you don't have good ideas yourself. If you run into trouble, somebody else can probably help you. So Electron uses Node.js for you to allow you to write fast JavaScript. It uses Chromium for you to write user interfaces, so you can build your interface. And then it has this thick layer of C++ that it basically packs around it, that is used to enable native operating system features. Things like notifications, things like the open file dialog, things like warning messages. All of those are implemented in C++ directly, and you're given the JavaScript API you can use to call those native methods. So Electron really is just those three pieces. And when we look at Electron and what Electron is, we're going to talk about processes for a minute. So whenever you start Electron, what you basically have is a Node.js process. And I want to make sure that everybody follows along. Have people here used Node.js before? Awesome. Great. Fantastic. So when you start Electron, you're basically running a Node.js process. It behaves the same way. There is no window. There is no anything. There is just a normal Node process. With one exception, in addition to all the features you have normally available in Node, you also have the Electron APIs available. And one of those APIs is the ability to open up a window, which is something you cannot do in Node. It's the ability to open up a new window called a browser window. So, when you call this API, you get something called the renderer process. It is slightly different from the main process in that it is an actual window. It has a document object model attached. In JavaScript, the window object is available, the document object is available. All those things are there. The cool part is that Node.js is also still available in this process. So if you open up the developer console and type require, it will be there. You can use anything that is on Npm inside your browser window. So it basically combines Chrome and Node in one window. But then, in addition to that cool part, it also allows you to communicate between those two processes. You don't just open up a window and forget about it. Those two threads can talk via inter-process communication. That's something you can't really do on a website. On a website, you have your little window, and that's where you live. And basically, as soon as you hit the edge of your window, you have no idea what is going on, right? You have no idea if the user has any other tabs open. You have no idea what kind of other applications are running. There's very little for you to do. In this world, you can open up as many windows as you want, and those windows can talk to each other, which allows you to build essentially multi-threaded applications. So if you run something like Visual Studio Code or Atom, and you pop up the task manager or the Activity Explorer on the Mac, or something that allows you to inspect processes, you will probably see a ton of little processes, right? The very same way Chrome works. You just see like a ton of little processes, because that's a very safe way of writing applications. It's also a very performant way of writing applications. If one of your threads runs into trouble, that's fine. You still have the main thread. You have control over this whole world, and you can deal with it. This is really the most complicated slide I have. This is it. Because now we will just briefly talk about what Slack is, and then we will jump into an actual demonstration. Okay? And just build a little app together. Little preview, we will be building a code editor today, because that's what people build in Electron, editors. Okay, so Slack. The Slack window contains of a bunch of technologies. Obviously, we use Electron. That's why I'm here today. That's what I'm talking about. We're also using TypeScript, because we know exactly which browser we're targeting. We can use whatever we want. We just have one compile target. So we can use all the latest and greatest that is available to us in JavaScript. And then, obviously, we use Node for file operations, but maybe the more interesting part is what we use C++ for. One thing that is like very commonly overlooked when you judge JavaScript applications is how much native code there is. Building an application in JavaScript does not mean that you're not writing native code. I don't know if any of you knew, but Slack has video calls. Those are not implemented in JavaScript. Those are entirely in C++. If you ever tried searching in Visual Studio Code, that is also entirely C++. So building an app in JavaScript really means that you build the easy part in JavaScript and HTML. You can do that quickly. And then you might have like 5% of your application that are really tough, really challenging. And you just build those pieces in C++. Whenever you see a JavaScript app that you think is slow, it's probably that the developer did 100% in JavaScript, right? It's building apps in JavaScript is a little bit like CGI in movies. If you only notice it when it's bad, right? You never notice it when it's good, because that was the point. You were not supposed to notice that there is some magic going on, right? Okay. So enough slides. We will now be building a little application. How many people here are using Atom or Visual Studio Code? Oh, that's not that many. What is everyone else using? Vim? Sublime? Visual Studio? Eclipse? Notepad? Okay. Well, so we will be building a little code editor. And before we do that, a little bit of history. So before Microsoft built Visual Studio Code, they built a thing called Monaco, codename Monaco, like the country. And the Monaco editor was really just the idea of JavaScript saying, how fancy can we make a text editor that lives in the browser, right? So they built this thing, which, if any of you have ever used Visual Studio Code, looks basically the same. And then at some point, one engineer, that happened while I was still working at Microsoft, one engineer basically said, what if we just put that into its own application and try to sell it as an editor? And then somebody else said, you're joking, but we should do that. So then they did, right? And it's very easy to do, so we're just going to do the same thing. Like building the core component of Visual Studio Code from scratch really takes, how much time do we have? 40 minutes. Not that long. We're going to be easily done in 20. So we're just going to go and do that. Let me quickly explain to you what you see here. Oh my god, that is dark. That is better, I think. Can you in the back still read that? Okay, cool. So let me quickly show you what is going on. We have my files on the left here, okay? Then we have the actual code on the right. And then down here is just a terminal, right? Where I can just do things. I can just execute terminal commands. And that's where we will be living. What I already have here is a package.json, the same manifest that you use to describe any Node application or any NPM module. Right? That's how you build a Node application. And normally, if you build a Node application, you use this line right here, this main equals index.js, to explain which file should be executed as soon as the application starts. So right now, if I execute this application, I get the error that nothing could be found. Right? There's no index.js. But I could just make one of those files. Just say index.js, could just say console log, and then a little message, right? If I save that file and execute this again, it's maybe hard to see in the back, but there's a little rocket down in my terminal, which means that the application executed. That is our app right here. It doesn't really do anything else. Right? So that works. And we can turn this very easily into a little Electron application. So the first thing we do is that we actually describe how this application should execute, right? Normally we would say start equals node dot, so I don't have to execute this node thing. I can, instead of writing node, I can write npm start, right? Just the same thing. So now our little rocket is here. If I want to turn this into an Electron application, it's very easy. I just install Electron, save def, or actually save Electron, there we go. And then it just goes and installs Electron from npm, which is where Electron is currently published. And depending on the internet here, this might take a second. Well, while that is running, we will be replacing Node with Electron. That's something we can do right away, right? We don't need to do anything else. And now we can still start our application. We can just say npm start. And as you can see, the same thing happened that happened before. Our application is executing. It's still just a normal Node process. Our rocket is still there, except that here we're doing it not with Node, but we're doing it with Electron. You might also notice that the application is still running, right? When we do it with Node, the application exits when there's no code left to execute. Electron just sits around and waits for a command from the operating system. Maybe the operating system wants to open a file or something, right? Cool. So let's make our little application a little bit more interesting. So we have a few things that we can do now that we cannot do in Node. Obviously in Node we can do things like this, right? We can say fs equals require fs, and that would be the file system in Node. But what we can do in, let me close this down here a little bit. What we can do in Electron is I can say require Electron. And that's a module that is already available. And on this Electron module, I have a host of objects and models and methods available to me. All kinds of things. The most important one being the application object. And that is really the core object that describes the life cycle of your application. Whenever there's an event that the operating system sends to your app, you do that with this application object. So the first event that I'm interested in is the ready event. That event is executed as soon as the application is ready and can receive commands from the operating system. If you want to open up a file, what the operating system does is that it starts the application, gives the application a little bit of time, and then it's like, hey, by the way, please open this file, right? So in here, let's just, again, do nothing super fancy. We can, again, just go with our little rocket, right? And if we start this, the same thing happens, right? Again, nothing super crazy. The application is ready. We receive the event. We start our application. Except that now we can make this a little bit more interesting and also require the browser window and make a new browser window. Currently with no options. So now, if I start this application, a window appears, which is something you can't do in Node. Ta-da! We now have a window. It is currently blank. It can't really do anything. There's nothing in here. But this is already a Chromium window. It has one major downside. It is not just white. There's actually no content in here. So if we open up the developer tools for this window, they crash right away. As it turns out, Chrome was not made to not have a website in it. Anything in Chrome is a website, even the settings. Everything is a website. Right here, we have nothing, so obviously nothing can be seen. Okay, so let's close our little application, quit this, and start thinking about what we can load. So the first thing I'm going to do is I'm going to make an index.html. I'm going to fill that with a little bit of code. Oh god, that's too much. That's not enough. That's just good enough. Okay. So what we have here is a most basic HTML website. There's absolutely nothing here. Hopefully you've all seen something that looks very much like it. There's really no content here. I'm going to add a little thing. I'm going to, just so we can prove that there's actually a website now, I'm going to say, let's make a little container. And then in here, classically, again, our little rocket, which is going to follow us around. So this is just a normal HTML website. There's nothing special about this. You could load this in a browser. We have a CSS style here, which currently doesn't exist, right? We do not have the style sheet made yet. So we're going to go ahead and make the style sheet. CSS style.css. There we go. Okay. So what's happening here, just to explain this a little bit, we're describing that the body should have no padding. It should go right to the edge, because an application doesn't have padding. It doesn't have any border around it. And then I'm also describing that this container should be the full height and width of the whole application. I just want this container to be as big as possible. And then about this editor, we're going to talk about this later, but the same thing. Once I start building my editor, the thing that is actually the component where people start typing text into, that should also be the full width and height. Okay. So I'm going to save that. I'm going to open up the terminal. I'm going to execute Npm Start. And again, nothing happens, because why should there, right? We haven't loaded the page. Currently, this thing has no idea where to go. So, close this, go back. Let me assign this a variable. I'm going to say const, or actually I'm going to say let main window. I'm going to say main window, close new browser window. And now what I can do is I can load a URL. That could be a normal website, but in this case I want to load something locally. I want to load file. I can use the special dirname command. If any of you have never seen this, this portion just refers to the current folder. This is just the current folder the script is in. And then I'm going to say index.html. Cool. So pretty simple stuff. We make a window, and then we tell the window, hey, please go and load that index.html. So we do that, and now it's a little bit hard to see, but there is our rocket, right? And if we open up the developer tools, you can see that we have full Node available. This is the whole operating system. You could run format C from here. You get everything available to you. There's no limits. I joked the other day that we should make our error page, we should change Slack's error page and just start deleting system files until we can blame the system. Just be like, well, your system is broken. But you have all powers here, right? We can just go and say fs. I can just say fs require. I can read the whole operating system, right? I can just straight up read the root system. Ta-da, this is my whole hard drive. You can do anything you want to do with it, right? From the power of this website. So at this point, it's really like, as a web developer, you have escaped the prison that is a browser. There's no limits. do whatever you want. Which is, of course, also scary, because there's a reason you were put into that prison, right? Because developers are terrible, and they will keep breaking your machine, which is why we like websites, because they don't break your machine. But in theory, you now have all the powers available to you. So, going back. For now, we're sort of done with our main process here. This index.js runs on our main process. And I want to start thinking about our renderer process, which is this window. I want to start executing code in our window. So, because I'm just running Node, I can just write the following thing, which is very convenient. Script. And just say renderer.js. And this works. This would not work in a browser, but this works in Electron because we're just running Node, and we can just load modules like we would in a normal Node.js thread. So I can now make a renderer.js. And again, we're going to start humble with our little rocket. Right? So now when I execute this application, we have the rocket here, as we should, but we also have almost a rocket here. That's very sad. Wait, let's go with... It's very disappointing. Well, that's sad. Normally I just use text, but I thought I'm in the country that invented emoji. I should use them. Well, I guess there we go. It's less exciting, but it also works. Okay. So now that we have this file and we can do things here, right? We have a normal renderer file. We can start thinking about our editor. So as we already discussed, the Moniker Editor is released by Microsoft. It is publicly available on NPM, and you can just install it like any other NPM module. You can just use it. So that is, in fact, what I'm just going to do. I'm not going to build this editor myself. I'm going to be lazy. I'm just going to say npm install Moniker loader, which is a thing that allows me to use the Moniker Editor. So I can now go ahead and just say const loader equals require Moniker loader. Well, okay, so. So what's happening here, just to explain this real quick, what is happening here is that I'm loading Moniker, the editor. That is what this loader does. And then I'm receiving the result as the Moniker object. So now I can do operations on it, right? Which is pretty nice. Okay, so let's just check out, sorry, I apologize. Let's check out this Moniker object and see what is going on. Okay, there we go. So this is our Moniker object. We can make a new editor, right? This is how that works. We can just go ahead and use the Moniker Editor as we normally would, which is really convenient. So what I'm just going to do is, instead of making this like in any way hard on me, I can just check out the playground, right? And use any of this. I can just copy this part right here, which is the most simple example. I can just steal this, place it here. We don't need the value. Forget about that. And what I'm going to do is I'm going to say const container equals query selector. Okay, just to explain what is happening. In this line, line number 4, I'm basically grabbing the container div that we made before, right? The div that is right here, this thing. It's going to delete the rocket. We do not want the rocket in our editor. But I'm basically going to put Moniker the editor into this container. And then I'm just going to create a new editor. It's pretty straightforward. One thing I already know I'm not going to like is that it's white. I would rather have a different theme. I think it's VS Dark or something. I want a better theme. This is not a good theme. Yeah, this is better. This is a better theme. Okay, let's just try this out, see if this actually worked. There we go. Well, that doesn't really work. But most things already work, right? We can say var x equals 1, and then we can say x, and it knows what x is, right? So we have a pretty basic editor. The one thing that we're missing is that the editor is just a fixed size, right? If we change this, that's not a good behavior. So we're going to turn on something that is called automatic layout, which is not an Electron feature. This is just a feature of Moniker. So if we do this again, right, you can see that the editor resizes itself. So now we have an editor, and if we wanted to, we could start editing our code inside this editor already. And that took us, what, 8 minutes? So that is what basically happened at Microsoft. And then somebody said, we should give this to people, because that will be a pretty good app, right? So to make this a little bit more interesting, there's a few things we want to do. The first one is, this editor can currently not open files nor save files, which is bad. That is literally the one thing you want a text editor to do, is you want it to open files and you want it to save files. Which is really also the difficulty you have with a website, right? A website can download files, but it cannot save them. You cannot open a folder. You can't really open a project. So if we try to do this in a website, we would be done here. You can copy and paste code, but you can't really open files that are on your file system. So the most basic way for people to open a file is usually to just take it and drag it onto the folder, right? If I actually take this very file, or index.js, and just drag it onto the website, what will happen is that Chromium steps in and just tries to navigate to the file. Instead of opening it in the editor, it will just navigate to the file. If I do the same thing in the browser over here, let's take this file. The same thing happens here, right? Chrome thinks, hey, I'm a browser, you want to navigate to this file, let me navigate you to the file. Normally, as a website developer, there's nothing you can do about that. If the user wants to navigate, you navigate. There's really no way for you to stop that. Mostly because we don't want web developers to be able to stop navigation, because then we would forever be stuck on every single website. Right? But we can. In Electron, you can do anything. So what we can do from our main thread, remember that is the thread where we created the window, we can control the life cycle of the application, we control the life cycle of the window, and of everything that is happening inside the window, to a degree that is not available to you as a web developer. So I can just say main window on, or actually, let me go one step further. I can just open the web contents, which are this crazy little object that is available in Chrome all the time. It is just that you as a web developer don't have access to it. It has features like toggle developer tools. Right? That's how you open the dev tools from Chrome land. That is something you can't do as a web developer, but Chrome always had it available. That is how Chrome is running JavaScript inside internally. It also has this cool method called will navigate, right? And then, if any of you know any events, we can do this, right? And that will instruct Chrome to not navigate. It will just not happen anymore. You're now stuck on this page forever. No unloading, no navigation. You will also receive the URL. So what I'm going to do For now, I'm just going to log it. Okay. Okay, so to explain this a little bit, we log the URL and then we prevent the default being navigation. So I'm going to start the application. We're in our editor. And now, if I drag this file on here, nothing should happen. And indeed, nothing happens. No navigation. Navigation has been prevented. However, back here, you can now see that we logged the location of the file. Since I have access to the whole operating system, I can just go ahead and basically read this file. Right? I can just like steal it. The only thing is that I can't read that file here. Doesn't really make any sense. I need to read the file over here in the renderer. That's why I need to do it. That's why I need to change the value of the editor. So I can now use inter-process communication. I can talk to that process. Even though there are two processes, I can have them talk to each other. So what I'm going to do is I'm going to say, so first let's copy this so we know what we're dealing with. This is our URL, right? And the first thing I want to do is I want to get rid of this. I want to make sure this is gone. Because this is really just a Chrome thing. If you open up a file anywhere in the native operating system, you never use this protocol. This is just not a thing. So I'm going to say URL equals URL slice 7. Okay. So that should turn this into this. Right? So we just got rid of it. And then I can just send this to my main window. No, I'm going to send it to the web contents because that's what I wanted. Okay. So I can define a channel, and then I can also define the actual parameters. So the channel should just be open file, and then the parameter should be the URL. So we're now sending this information to the window. Right? Pretty straightforward. We're just saying, hey, here's the URL. So in the renderer, we can receive these things. We can say const IPC renderer equals require electron. And that is just like app or browser window. This is just another module I have available where I can receive events. So what I can do down here, I can say, first let's make this an actual editor. Okay. And on here I can say IPC renderer on open file should just be the URL. Console log URL. Okay. Let's see whether or not this actually works. We will figure this out. But we now have our console here, and if I take this file, there is now not my URL, but the event, because I made a mistake. There we go. As we all know, the first parameter in an event is always the event itself. So, let's try this again. Open up the DevTools, take this file, drag it onto here, and there's our file. That is exactly what we wanted. And now to make this a little bit more interesting, we can just read it. We can just say const fs again equals fs, and then instead of just showing the address to the file, we can just say console log fs read file sync, because we're lazy, URL. Okay. There we go. Do the same thing again. Open up the DevTools. And now we're going to get a few steps closer. We're not very close because this is a buffer, right? This is a raw buffer because, again, we're living in Node land here. And if you don't tell Node what is going on, Node will just give you what it can see, which is a buffer of the actual bytes. Do not fret. We can just specify the encoding. Thank you. We can just specify the encoding. Can now drag the file onto here. And now there is our contents. So now we're just one step away from actually moving this into our window. It's pretty straightforward. You can just say const file content, right, that's that. And then I can just go and say editor dot value. I'm not entirely sure this actually works. Yeah, actually, let me try that. It's a little bit lazy, but it's good enough. I'm just going to make a new editor. Every single time you open a file, new editor. Okay. Okay, so once we drag this onto here, I guess that didn't really work. That's kind of sad. Because we already have an editor. That is fine. We'll just be lazy because we have only 5 minutes left. We will not create an editor right away. There we go. That's easy enough. There we go. That's easy enough. Cool. So that is really it. That is the demo portion. Visual Studio Code and any other Electron application is built exactly like this. It's not more complex. There's more of the same pattern. There's more objects in Electron. But really, everything works like this. There's no great difference. Opening up a new dialog, sending notifications. It is all exactly as simple as what you just saw. So, real quick. 3 more points. The first one is that you have everything available to you on NPM. Literally everything. If you want to use SQLite, if you want to use whatever module you like on NPM, you can use it in Electron. But also, there's already 1,700 modules specifically for Electron that make pretty common operations easier. I, for instance, wrote a module for sending really fancy Windows notifications. The ones you receive from Slack are open source if you want to use them. Things like setting a different menu, making a fancy window. Somebody even at some point did like a thing, Electron Vibrancy, just as an example. This is a bad demo. Vibrancy is just like this feature that allows you to make transparent windows, right? So if you ever want your Electron window to look like this, that is something you could have used, right? There's 1,700 modules. They're all pretty amazing. You should use them. They make life easier. And then beyond that, there is a tool called Electron Forge. If you feel like you want to give Electron a try, you want to try this out, we, the Electron maintainers, have started working or promoting this Electron Forge tool, which is a command line tool that makes common operations easier, right? So if I just execute Electron Forge, it sort of works like the Ember CLI or Create React app. It makes it a little bit easier to get started, right? You can, instead of doing the same steps that I did today, you can just say Electron Forge init my cool new app, and then it goes and gives you the basic setup for an Electron application, right? So, in summary, we in Slack, and I in particular, really enjoy building apps with JavaScript. It allows us to have a small team. It allows us to be nimble. It allows us to ship very quickly. And also, it's a pretty good community. NPM is the leading open source ecosystem out there. As someone who's worked in C++ and C#, it is a lot easier to find battle-tested good solutions written in JavaScript than it is to find the same for C# or C++ or Objective-C. It is just harder. In JavaScript, things are already there. You usually do not have to reinvent the wheel. You don't have to start from scratch. If you want to get started, you should check out Electron Forge. You can just Google for it, which should help. And then the very last point, should you at any point have questions about any of this, you can find me ideally on Twitter, which is, if you want a response from me, that's the easiest way to actually reach me, because I don't really check emails all that often. But if you want to send me an email, if you have a question, you can find all my contact details on this address. Okay, so now I think we have time for Q&A, right? So if anybody has any questions, now would be a good time. I think we even have translation, so you can just ask me in Japanese, and then magically I will understand it. It's very convenient. Yes, please. I think we have microphones. Yeah, thank you. That's a good question. Memory is one of the #1 concerns that people have. It is actually not all that bad. The reason memory consumption is usually high is because the web applications are written in a non-performant way, Slack included. Slack has a long way to go to get rid of memory consumption. When Slack uses too much memory, it is not because of Electron, it is entirely because of Slack, to be clear. We're currently moving the application to React, and we have many ideas for making Slack a lot leaner. But that's the main reason, is that Slack grew very quickly as a company, extremely quickly. But there's a few things, as an example, if you have 10 teams, we will have 10 connections to the Slack server. That should just be one, right? If that makes sense, right? If you're on Facebook, you don't have 50 Facebook connections for each one of your friends. In Slack you do, but we're going to work on that. So it's really not Chromium. If you look at something like the activity monitor right now, you can check out Visual Studio Code, right? It's right here. It's 120 megabytes for an IDE that debugs. Visual Studio, for instance, uses gigabytes. So Visual Studio Code is doing a very, very good job. Slack could get there at some point, but it's not Electron's fault. So it's really up to the developer to build an application that optimizes memory and throws things away when they don't need them anymore. Thank you. Yeah, that's a good point. So for many people, it's a gradient, right? You sort of have JavaScript on one end, then you have JavaScript that is written in a very performant way in the middle, and then you have native languages in the end. And it is really up to you to figure out which pieces you should build in which language. Good example for me would always be, there's this feature in Windows called quiet hours, which is really the same as this, right? It prevents notifications from getting through. And there's a lot of code that I tend to implement natively in C++. And that would be one of them. So whenever you feel like, sorry, I'm trying to show this code. There we go. So whenever you feel like you need to implement something natively because you want it to be a little bit faster, that is something that is available to you. So this would be a typical example right here. It's very simple code, right? This is very simple C. There's nothing super exciting about this. The only reason I'm showing this is because I'm showing that this is code that runs inside Slack. So whenever you feel like code is a little bit too sluggish and not quick enough for you, that is when you have the availability to write it in C# or C++ or whatever native language you prefer. It really comes down to what you think is better. In Slack's case, we briefly sent notifications using in C#, but then realized that it wasn't JavaScript that was slow, it was just Windows that was slow. So we ripped out C# again and replaced it with C++ because that is the only way we found notifications to be actually quick. And by the way, even today, Windows is sometimes pretty slow when it comes to notifying people. But the choice is yours. Really. Those are very good questions, by the way. Slack co-maintains Electron. We're very proud of working directly with GitHub on Electron. And by the way, I don't know if people knew, but the lead engineer actually lives in Tokyo. Not for Slack, but for Electron. So we work directly with GitHub on maintaining Electron. We use Electron directly. And I think we had one more in the back. Oh, that's a good point. Testing is a very important topic. There is many schools of thought. There is two things available to you, generally speaking, on both bookends. One is something called Spectron. Actually, excuse me, three. There's three things available. One is called Spectron. If you know Chrome driver by any chance, which is Google's way of testing Chrome from the outside, where you can write very simple scripts to control Electron, that is available for Electron. So let me just show you some code because I think that would make this easier. So you can write JavaScript that launches an application and inspects it from the outside with any given test runner, right? So I don't know if you can see this, but this is some fairly typical testing code where right here we launch an existing application and down here we check that the window count is actually equal to 1. This would be a very simple test that just says, does my application actually test a window? So this is one way, testing Electron from the outside. The other way that is very popular is testing Electron on the inside. So instead of trying to do this from the outside, you actually launch your test script inside Electron and then run your scripts there, which has the benefit that you do not need to worry about missing APIs. Because in this case, you can only inspect things from the outside, but you can't really run your unit tests inside Electron. In the second case, if you have methods that use native Electron features, you can test those. And then the third feature, the third possibility is to essentially mock Electron. And that is what we do at Slack. We test with a framework by Facebook called Jest, which I will also show real quick, called Delightful JavaScript Testing. It's made by Facebook. It is extremely good. What we do is that we assume that the Electron API is stable. We don't actually need to send a notification. We don't actually need to open up a browser window. So we mock everything that is Electron and run our JavaScript tests entirely in Node using Jest. But that's a very good question. Thank you very much. Okay. Well, thank you so much. I hope that people now go and build applications. It is extremely easy. this quarter, Slack will have 2 engineers. It's me and a colleague. So it is extremely easy to build like a little, very impressive application. And if you want to try anything out, the code editor is also available on my GitHub. If you search for the name Electron Code Editor on Google, you should find it. And if you ever have a programming interview and people ask you which editor you use, answering with, oh, I use my own, is usually very good. Okay, well, thank you very much.